Any questions?
Yeah, could you maybe do a problem like I think it was 44, the one that had a issue when you It was the naturally occurring charge in the ground on a fine day out in the open country is -1 nanocoulomb meters per second. What is the electric field?
You said 44, okay.
Yeah.
Hours on the ground on a fine day. Alright, so it gives you a surface charge density. Alright, so when you're at height of 3 meters, so that's basically from the floor to ceiling. The at that point, the ground is considered flat. So, and matter of fact, at 3 meters, if I can go out, if it's flat for 30 meters by 30 meters, which we will assume, open country, we can assume infinite plane is approximation. So if you're dealing with an infinite plane, am I covering up the eraser?
Yeah, it's under your book.
Pardon?
It's right there under your book.
Oh, I am covering it up, thank you. So once you establish that the infinite plane approximation is valid, then the electric field, magnitude of the electric field is sigma over 2 epsilon sub naught. And so therefore, in this particular case, -1 times 10 to the -9th coulombs per square meter divided by 2 times 8.85. God, this marker sucks. That's even worse. Let's pretend this will work. There we go, times 10 to the negative, oops. Yeah, 10 to the -12 coulomb squared per. You work it out, you get an electric field. The other thing about the infinite plane approximation is that the electric field is constant. So if we're trying to find the electric potential at that, well, B is a little bit questionable about how you want to interpret it. I believe the intent is you're using the N equation, and they actually want you to find the potential difference between the ground and that point. The electric field is constant, so we can use this equation. If the electric field is constant, then we have negative whatever that is. My electric field is heading towards the Earth. If I'm finding the potential difference relative to the ground at that point, okay, so they are looking for a potential difference. I'm going this way, so I'm going to have a drop in electric potential because the electric field and the direction I'm going in are opposite. And so times 3 meters. And then to be, oh, actually, it'll be we'll have a gain in potential. Because the dot product will give me a negative, and then the negative sign there. And then it asks for what, equipotential lines?
Yeah.
That's my electric field. And equipotential lines are perpendicular to it. Do you want to be, I feel like I dashed through that.
No, I get what you did. My problem with it was on the out, like the not on the paper, it was like, this problem was done wrong, I think they didn't put the two, the epsilon, stuff not.
Oh, they left the two off?
Yeah, and I think you just sent a message about it, and I just didn't get the difference.
But you generally drop the two if you've got parallel plates as opposed to just one plate.
Now, on the actual question on the PDF, it also has it as sigma over epsilon.
That's what Jack just mentioned.
So it's supposed to be two epsilon, so not just epsilon.
Yeah, you would use just epsilon if, I'm trying to think of a justification for it, but you would use just epsilon if you had two parallel plates. So if the ground is negatively charged, is there anything to indicate that there's a positively charged anything above it? Naturally occurring charge on the ground on a fine day in the open country. There's nothing in there that make me think that there's a positive charge above it. If there's a positive charge just below it, then the electric field would be zero. Because then you would have like parallel plates here and looking at a point up here outside of it. So, I'm sticking with it.
And then one more question, when adding capacitors, if they're in a series, it's 1 over,
Yes.
and then if it's parallel, it's just adding.
Yes.
Can you see like
Switch, sorry, you switch those after when you get the answer.
Say it again?
Conflict the denominator and numerator, that's when you get the answer.
If they're in series, you add the reciprocals and then take the reciprocal of what that answer is. Is that answering your question? Other questions?
When you put that, because the arrow into the equation, are we gonna automatically put that number at negative?
Oh, in here? Yeah, even though I put absolute value marks around there. If I'm looking for just the strength, there's no negative if it's just the strength. But the negative sign is indicating direction, indicating towards the ground. So, the question here is, what is the electric field relative to the ground? So, however you want to indicate towards the ground. Okay, in B it says calculate the electric potential at the site. Now the simple answer is the electric potential at that height. What is the simple answer?
Zero.
Why? Remember, you are mighty.
Because it's outside of the range.
That's not why.
Cause he said so.
Yes. The way the question is worded, you could get away with 0 volts, don't forget the units, because you say so. That is not the intent of the question. This is one of the textbooks that's using voltage and electric potential almost interchangeably.
Can you just go through a quick, like, problem on 61?
Okay. I don't know why I'm trying to memorize those, because I'm just gonna forget by the time we walk over here. calibration? It's looking like it. All right. And then 5, 3.5. 8, 1.5, 0.75, and 15. Those are microfarads, so let's not forget to tack that on at the end. All right, so they're asking for equivalent capacitance. These lines sticking out here indicate sort of where the probes would go to figure out what the total capacitance is. And so we now just start looking, do we have any parallel or series that we can combine?
Well, you could do the series, right, and go ahead and combine the two.
Which two?
Well, you could do 5 and then 3.5. And then, the 8.5?
No. Series. Capacitors and
Oh, so
resistors
it's
are
the
different.
reciprocal?
Yes.
Oh.
So series, reciprocal. So 1/5 plus 1/3.5 is 1 over the equivalent resistance. And whatever that ends up being. Let's see, that's 2/7. 35, so 10, 7, 17. 35ths. So my equivalent resistance would be 35/17, unless I made a careless error.
Wait, aren't we talking about capacitance?
Yes.
Why are we saying resistance? So why are we talking about resistance?
Oh, did I say resistance? Oh, sorry, capacitance.
You have an R under the one.
Happy now? Yeah, sorry about that. Thank you. Did I do the math right?
Oh.
I got a nod there?
So.
And then, 15 and 0.75 could be added together.
Yep. So that would be 15.75. All right, so we've reduced it down to, let's see, I got one here that is 35/17, unless somebody corrects me. I have one here that's 8, and properly drawn, that line should not be there in between. We got 1.5 and 15.75.
I might be wrong, but do you need to flip the fraction, or did you just do that by accident? 35/17, it was 17/35.
Oh, that was, when I add those together, I get this, but then I take the reciprocal. That's 1 over the equivalent capacitance.
Okay.
And then you do like 1.5 and 15.75.
All right, we can combine those next. So 1 over 1.5 plus 1 over 15.75 is 1 over the equivalence. I'll put a little subscript 2 there because we're combining different ones. That one I'm not gonna do in my head, but someone is going to reveal the truth.
1.37.
So I now have, so this is 1.37. So now I have this 1.37 and 8 and 35/17 in parallel.
So then would you just add all of them up?
Yep. And so my total equivalent resistance is 9.37 and 35/17 microfarads. This would not be an acceptable answer. Only 1 fraction bar per answer, and I consider the decimal equivalent to a fraction bar.
So you guys just want us to find out what the 35/17 is and put it in? or just turn them all into 7 feet?
Personally, I think the calculator would be easier, giving it to me in a decimal, but
So you're saying you either want it all in a fraction or all in a decimal?
say it again?
You either want it all in a fraction or all in a decimal?
Yes. And this is not multiplication going on here. It's like a mixed number where, except no integer up front. Okay, other questions?
On, number 3, is the speed of light, is that 3 times 10 to the 8?
Sorry, number 3. So what was your question?
The speed of light is 3 times 10 to the 8?
Roughly, yeah.
Okay. And then 1/2 mv squared, that's just the kinetic energy formula, right?
1/2 mv squared is indeed the kinetic energy formula, which everyone in here should know. Especially, Billy's the only one who possibly has an excuse here. The rest of you, you know that you
Help
should
me
know that.
God.
Pardon?
So help me God, I should strike that down.
And then, what are electron volts?
That's a unit of energy that if I take I know that the voltage is equal to the change in electric potential energy divided by whatever the test charge is. So if I multiply by Q, so if Q delta V is equal to delta U. The electron volt is the change in potential energy if I take something with the charge of an electron and I take it and it moves through 1 volt of potential difference. So basically the electron volt, that is just a unit of energy.
So how would you go about doing that? So to find the electron volt, you would also, you would have to know your base voltage, or what the.
No, if I-
Or
Well, it depends on what, if you wanted units of electron volts, then it be 1 electron volt is the amount of change in potential energy to take an electron or something with that charge. So that would be 1 electron volt. If you want to put it in terms of joules, then that would be, that's still 1 volt. This is 1.6 times 10 to the negative 19th. Coulombs, and so 1 electron volt is 1.6 times 10 to the negative 19th.
Yeah, because on here it's, you multiply the joules you get from the previous problem times 1 electron volt over the charge of an electron, or,
Yeah, the conversion.
yeah, okay. And then also you round it and answer A, but then you use the non-rounded version and answer B.
Presumably that's what the textbook did. When you are dealing with significant figures, you round when you present the answer, but if you do any calculations, you should use the entire number, not the rounded number.
Yeah.
You only round it when you present. When you get into high energy physics, you tend to talk about, you eventually get a relationship that E equals mc squared. So, since speed of light is a constant, the general philosophy is that, well, we can use energy and mass interchangeably. Technically, you would have a mass is equal to the energy divided by c squared. And so the units of mass, if you're doing this, typically are electron volts per c squared. However, so when you talk about the mass of tiny particles, you tend to talk about in terms of electron volts. It's understood, you're just supposed to know it's divided by c squared. But then you can use naturalized units, and in naturalized units, c equals 1. Big G equals 1.
Let's go throughout the entirety of the course just using naturalized units.
The trouble with using naturalized units is then you start getting equations like, well, if C is equal to 1, then E equals M. And it gets really confusing, in my opinion.
I can see it.
Other questions? Ethan?
Yeah, on, number 24, why is the distance on the bottom 2.5 times 10 to the negative 3 and not 2.5 times 10 to the negative 5?
It's 0.5 centimeters,
Yeah.
which would be 5 millimeters. So 2.5 millimeters would be the radius. So they're using 2.5 times 10 to the
Oh, it's
negative.
not squared, okay.
Okay, you good?
Yeah.
All right. Other questions?
Yeah, I got it.
Ethan?
Yeah. For 43, when it's the one with the pole and you draw the lines,
Yep.
it said, indicate the direction of increasing potential. How do I do that? How do you do that?
All right, so if I have